Hi, in this video I wanted to show you how to calculate the area under the curve for a normal distribution using your TI-84. Okay, so in this problem I want to find the area of this shaded region, and I'm given that this is a standard normal distribution. So two things that you want to know with a standard normal distribution: mu, the mean, the population mean, is equal to 0, and the standard deviation, sigma, is equal to 1. So let me go over to my distribution functions. So this is a standard normal distribution, and I want to calculate the area. So I want to go to normal CDF. The C, if you recall, is cumulative, so I want to find the accumulation of all of these points. So I'm going to click enter. So you'll notice that with the normal CDF there's two arguments or two variables that you need to input. You need your lower bound and your upper bound. The mu and sigma here, they're pretty standard. That's 0, 1, standard normal distribution, so we're good with that. So in this problem, the lower bound is negative infinity. It's all the way over here, all the way to the left side. So that's negative infinity. Negative 1 e to the 99, that's basically scientific notation for negative 1 by 10 to the 99 power. So that's a very small number, which is what we want. The upper bound here is that farthest value on the right, or the largest value, and that corresponds to a z-score of 0.44. So that's what we want there. So 0.44, click enter, enter. We want to paste that, enter to evaluate that, and we get our answer of 0.67 approximately. So what does that tell us about this problem? Well, that tells us that the area is equal to 0.67. And if you remember this whole thing, if I look at the whole thing, the whole area is equal to 1, but just that part that is shaded here is equal to 0.67. And also, another important thing to note is that there is a correspondence between area and the probability. So if they ask for the probability of given this range of z-scores, then that probability is equal to this area. Okay, so there's actually another type of problem, very related, but what if we're asked to find this area, so to the right? Well, if we go back to our function, the normal CDF, the lower bound and the upper bound are now different. So the lower bound, the value farthest to the left is negative 1.0. So in the lower bound, I'm going to put negative 1.04. And the upper bound is the largest value to the right. Well, that's going to extend to positive infinity. So I can either do the 1 exponent to the 99, or I can put a very large positive number. Either one will work. So now that I've got my lower bound, upper bound, let me click enter, paste it, enter, and that gives me an answer of 0.85. What is 0.85 again? That's the area under the curve, that shaded part right there. Okay, and now there's one more problem as well. So this problem is different because we have two specified lower bound and upper bound, two z-score that correspond to those 2 points. So if I want to calculate the area of that, again, go to normal CDF. The lower bound here is negative 0.84. So let me put negative 0.84. My upper bound for this problem is 1.28. 1.28. My standard deviation and mu are all correct. So let me put paste, and that number right there, the 0.699 approximately, corresponds to the area of this shaded part. And also, just kind of to repeat myself, that corresponds to a probability of the distribution falling between negative 0.84 z and 1.8 z-score. Alright, so if you have any questions regarding what I just did, feel free to shoot me an email or ask me in class.